Hello, everyone, and welcome to this webinar on carbon capture and storage in the GCC region and around the globe. I'm Jeff Erickson, the General Manager for Client Engagement for the Global CCS Institute, and I will be moderating the event today. We have with us an outstanding set of speakers who will be sharing their unique perspectives on the current state of carbon capture and what we can expect going forward. But before we do that, just a couple of comments specific to the Gulf region. First, I'd like to congratulate the people of the United Arab Emirates on their 50th anniversary as a country coming up later this year. The UAE has been a place of extraordinary progress over the last 5 decades, and we expect that the next 50 years will likewise be a period of remarkable achievements. The Gulf region has for decades been an area of great importance to the global energy picture. In the next several decades, it will remain a critical region for the world's energy, but will also be key to addressing climate change. Carbon capture and storage, or CCS, is one area where energy development and climate change mitigation converge. We anticipate that the Gulf, with its extensive expertise in managing fluids below ground, an excellent geology for CO2 storage, and the motivation to decarbonize, will be a key player in the advancement of CCS. We hope that this webinar will support the CCS efforts of both business and governments in the region. And to further advance CCS in the region, the Global CCS Institute, for the first time, has published our flagship report, The Global Status of CCS in Arabic. It's available on our website now on the registration page for this event and will be placed even more prominently shortly. The Institute has had a significant increase in the last year or so in our involvement with organizations based in the Gulf region, and we expect a further increase in such engagement in the months and years ahead. If your organization wants to get involved with us, please reach out. We'll provide contact information at the end of this webinar. Next slide, please. Before we start, a few words about the mechanics of this webinar. You can adjust the view settings by clicking on the view tab in the top right corner of your screen. And if you have questions for any of the presenters, you can submit them through the Q&A function on your Zoom control panel, typically found at the bottom of your screen. I will be posing a selection of those questions to the panelists when all of the panelists are finished with their presentations. So on to our agenda, and if our panelists could please turn on their cameras. We'll start with a global overview of CCS presented by our General Manager for Advocacy and Communications, Galoran Turan. And much of what Galoran will be presenting is reflected in our Global Status of CCS report, which we published in December of 2020. Then we'll focus in on the Gulf. We'll start with a regional overview by Robin Mills, the CEO of Qamar Energy. And Robin will be followed by Tijani Nias of Saudi Aramco to talk about CCS in Saudi Arabia. Tijani will be followed by Aisha Al-Kabali of Abu Dhabi National Oil Company, ADNOC, who will discuss CCS in the UAE. Then I will field questions from the audience, and I may have a couple myself for the 4 speakers. And we'll go all together for about 75 minutes or so today. So thank you again for joining us. With that, let me pass over to Galoran.
Thanks very much, Jeff. Hello, everyone, and thank you for joining us for this event focused on discussing CCS momentum in the GCC region as well as around the world. The status report is authored annually by the Global CCS Institute. It provides a comprehensive overview of progress of carbon capture and storage developments around the world. And before we hear from our distinguished speakers, I would just like to present you with some of the key findings of the report, which, as Jeff mentioned, we released on 1st of December. And for the first year, it's also available in Arabic, and you can download it from our website. Next slide, please. In 2020, the pipeline of CCS facilities, both operational and under development, continued to grow for the 3rd year in a row. 2020 was undoubtedly a very challenging year because of the pandemic and its economic consequences. But from a climate point of view, it was also a year of building back better, with an increasing number of countries, cities, and businesses committing to net zero emission targets. There is also growing recognition that reaching net zero without carbon capture and storage is going to be extremely challenging, if not outright impossible. And as a result, government support around the world, both in terms of policy and funding for CCS, continued to grow. And in fact, we saw CCS feature take place in a number of recovery packages in a number of countries around the world. In addition to the net zero targets, when we look at the drivers that have been accelerating CCS around the world, we find it worthwhile to highlight three. Firstly, enhanced tax credits, otherwise known as 45Q in the US. US is without a doubt a leader in the CCS scoreboard, with the largest number of facilities in operation and under development. In fact, last year, we added 12 new facilities in the US to our database, and this is due to a large extent for US having very advanced and most advanced CCS specific policies around the world, both at the federal level, as in the 45Q tax credit, but also state level policies such as the low carbon fuel standard in California. Secondly, we're seeing hub and clusters emerging quickly as favorite business models for CCS development. Hub and clusters help reduce risk, they help reduce cost, they facilitate regional industrial decarbonization, and we find that governments, project developers, banks, and local communities all like them. And I'll talk a little bit more about hubs and clusters in a moment. Thirdly, hydrogen, which has long been called a fuel of the future, but that future is becoming very imminent. And of course, we're seeing significant interest in the GCC region in clean hydrogen production, low carbon hydrogen production as well, with through the use of CCS. And we believe that blue hydrogen is likely to remain competitive in locations where there isn't an abundance of renewable energy and fossil prices continue to be low. However, despite all this good news and despite all this progress in 2020, one thing we should not lose sight of is the fact that this progress is nowhere near enough. And in order to meet net zero targets by the middle of the century, CCS capacity must increase by 100-fold over the next 30 years, which is no doubt hugely challenging, but we at the Institute believe is certainly, it's not insurmountable. It's something that we can and we must do. Next, please. In 2020, we introduced a new system of CCS classification. In the past, we used to focus on capture capacity and differentiate between large-scale projects and pilot projects. This has become less helpful over the last year or so, last few years actually, because hub and clusters now offer shared transport and storage infrastructure and enable multiple smaller sources of CO2 to be connected to this infrastructure and thereby making them commercial. As such, our new classification sort of puts facilities either into commercial category or we can classify them as pilot and demonstration. And based on this classification system, there are a total of 65 commercial facilities in the pipeline. Of these, there are 26 of these facilities are operating at the moment. 2 have suspended operations. These are Lost Cabin and Petronova in the US. We have 3 commercial facilities under construction and 34 facilities in various stages of development. Since the 2019 status report, we have added 17 completely new facilities to the pipeline. And as I mentioned, 12 of these are in the US. The complete pipeline of 65 facilities have a cumulative capture and storage capacity of around 115 million tons of CO2 per annum. And last year, from these 26 facilities, the commercial facilities that are in operation, almost 40 million tons of CO2 has been stored and captured, and stored safely underground. Next, please. Here is a world map of all CCS facilities. These are both commercial facilities and pilot facilities around the world, which shows where the concentration of CCS activity is. And as you can see, the GCC region, as well as North America, Europe, and Asia Pacific are leading in terms of CCS deployment. Next slide, please. And here's a pipeline. Here's a bar chart of CCS pipeline development historically. As you can see on the left hand of the chart, after a fair bit of attrition in the early years of the decade, in the 2011s and 12s, the pipeline has been now growing for the third year in a row and almost doubling in capacity since 2017. And there has been an increase of 33% in the pipeline capacity since last year, so year on year. Clearly very dramatic momentum in the CCS pipeline development. Next slide, please. Here is a bubble chart of CCS pipeline development across the different applications of CCS. This particular chart shows facilities that are either in operation or that are in advanced stages of development. So it doesn't include all of the 65 facilities. On the y-axis, we have the different applications of CCS, and on the x-axis, we have the year on which they either came online or they're expected to come online. A few things that I want to point out about this chart. Firstly, the diversity of applications that you see on the y-axis. And this range of applications, I think, very successfully underline the versatility of CCS as a climate mitigation technology. We have heavy industry, there's power generation, there's hydrogen production, chemicals production, gas processing, and you name it. Secondly, when we look at the historic evolution, we see that in the 1970s, 80s, in the earlier decades of CCS deployment, most of the early facilities were concentrated in gas processing and chemicals and fertilizer production. However, looking forward, we see a much more diversity in the number of applications, different sectors of that CCS is applied, and we are soon to have the first commercial CCS plants on cement and waste to energy, as well as the first CCS capture plant on natural gas, capture and storage plant on natural gas power generation. And again, talking of power generation, the final point I wanted to make is, you can see the big increase in the number of gas and coal-fired power plants with CCS that are being developed at the moment. Next slide, please. Early developments of CCS adopted mostly a point-to-point model, where a single emission source was connected through a dedicated pipeline to a dedicated storage site. However, like most industries, carbon capture and storage benefits from economies of scale, and therefore hub and clusters are quickly emerging as the preferred business models for CCS, for developing CCS chains. Hub and clusters involve connecting multiple emission sources through a shared transport infrastructure to a shared storage facility or storage facilities. And this is a preferred business model because it reduces interdependency risk between the different parts of the different players in the value chain. It enables the different parties to concentrate on what they do best, i.e. an industrial plant will capture its emissions, but it doesn't have to build a pipeline, and it doesn't have to build the storage facility, and which is not its core competency. Hub and clusters also enable scaling up of infrastructure and thus lead to lower unit costs as well. On the right-hand side of this chart, you can see the Longship project in Norway, which is one of the most advanced hubs in development at the moment. Its storage This transport and storage infrastructure is usually referred to as Northern Lights. Longship project initially aims to capture CO2 from a cement plant and potentially a waste to energy plant in Norway, but it's been scaled up to store emissions from Europe. And this map shows the potential candidate emission sources to send their carbon CO2 to Northern Lights. And as you can see, it's an impressive number of potential candidates, a very much regional, European regional development opportunity under development. Next slide, please. And here is a map of hub and clusters around the world. There are at least a dozen, and you can see and read a little bit more about them in the Global Status Report itself. Next slide, please. Now I'd like to give a short overview of the regional developments. And as we look around the world at the various regions, there is one theme that resonates across them all, and that's momentum. We see both public and private sector support for CCS and investment growing in a number of regions. Next slide. Oh, sorry, here. When it comes to CCS, North America, in particular, the US, leads the scoreboard with the largest number of facilities in operation and under development. There are 36 facilities in North America that are in operation and or under development, and 2 of them plus the 12 that have been idled, which accounts for roughly half of the global total. As I mentioned, 12 of the 17 new facilities that we added to the project facility pipeline last year are based in the US. In the US, big news of 2020 was the finalization for the implementation rules of the 45Q tax credit, which together with, as I mentioned, other state level incentives such as California's low carbon fuel standard helped make the business case for CCS. The facilities under development in the US are quite diverse, with sectors such as waste to energy, cement, ethanol, chemicals production, as well as gas and coal-fired power generation. And here in the report, we mentioned the US Congress allocating north of $200 million for CCUS, but in December, the Energy Act, the Congress passed the Energy Act with even further funding and support and enhancement to the 45Q tax credit. So support for CCS is very much on the increase, alive and on the increase in the US. In Canada, across the border from the US and Canada, Alberta Carbon Trunk Line started operations in 2020. It's currently capturing CO2 from 2 facilities, a refinery and a fertilizer plant. And the pipeline is scaled up significantly, even though the capture capacity from these 2 facilities is around 1.6 million tons. The pipeline is scaled up. It's around 14 million tons per annum capacity. And it's a great example of private-public partnership where both the regional and the federal government provided support to realize this backbone infrastructure, with the private sector taking on operational and commercial risk. And of course, in Brazil, in the Santos Basin, Petrobras continues to capture and store CO2 since the project began operations. And to date, 14 million tons of CO2 has been captured and stored. Next, please. Moving across the ocean and looking at Europe, we are seeing growing CCS momentum across the continent. There are currently 13 facilities in operation or under development, and most of them are actually hub and cluster models, notably around industrial ports, which have, of course, high density of emission sources. 2020 was notable in terms of developments, government support in the EU, in Norway and UK, the traditional hosts and countries with interest in CCS. But we also, it's worth pointing out that CCS is now being developed in other countries in Europe, and notably Denmark, Sweden, Italy, and others. So it's becoming much more of a sort of continental European phenomena. In 2020, the European Commission has put out the first call for what was to be, or what's actually known as the 10 billion euro innovation fund, but it's actually 450 million carbon allowances, EU ETS carbon allowances. And since we put out the report and since the first call, the price of the allowance actually increased significantly to 40 euros a ton, or around 40 euros, and therefore now this fund is around 18 billion euros. But we understand that around 60 CCUS projects have applied and in various different applications, and the decision on the first call is expected before the end of the year. In the United Kingdom, which is where I'm based, there is a 10-point climate transition plan, and CCS is one of the components of the plan. The government aims to have 4 CCUS hub and clusters in operation before 2030, and has earmarked £1 billion of infrastructure fund to support CCS development. And of course, last but not least, the Norwegian government has given the green light for the Longship project that I mentioned, and is committing around $1.8 billion for this investment. Next, please. Moving to the GCC. This is an area of great potential for CCS. Currently, there are 3 facilities, commercial facilities in the GCC region, capturing and storing close to 4 million tons of CO2 per annum, which, to put into perspective, accounts for around 10% of global capture and storage capacity. The El Raida facility in Abu Dhabi captures CO2 from a steel plant, and it's worth noting that currently it's the only one of its kind in the world. The other 2 facilities are in the GCC are, of course, the Othmania facility in Saudi Arabia and the Qatar LNG CCS facility, and these are both in gas processing. Commitment to action on climate change is intensifying in the region. CCS, we observe, is a strong component of the GCC countries' national low carbon plans, along with renewables, efficiency, and replacing oil and coal with natural gas. Both Saudi Arabia and the United Arab Emirates have issued ambitious climate strategies to diversify and decarbonize their economies, and submitted climate plans that are called Nationally Determined Contributions, or NDCs, to the UN that explicitly mention the role of CCS. As regional and global interest in low carbon hydrogen grows, with its vast underground CO2 storage potential, abundant natural gas resources, and of course ample production capacity, the Middle East we expect will use its developing CCS expertise and location to develop a clean hydrogen export industry as well. And of course, this was just a sneak preview. We'll hear a lot more about the developments in the GCC region from our distinguished speakers in a few moments. Next, please. Looking at the Asia-Pacific region, there are currently 2 facilities in operation and 8 facilities under development, so a total of 10 facilities in the pipeline in the APAC region. The model that's developing in this region is collaboration between governments, where, for example, there is one country with high emissions and a strong emission reduction target versus another country that has, let's say, emission storage resources and/or know-how, and we see collaboration between countries. Japan, for example, is driving international activities to develop clean hydrogen production using CCS, and uses CCS both as a domestic as well as a sort of export potential opportunity. Several governments in the region have developing CCS strategies. The Australian government now has a specific $50 million Australian fund to encourage further CCS development. China, in addition to South Korea and Japan, has announced a net zero target and it's currently working on its 14th five-year plan, and we expect to see CCS being part of the recommended actions. Next, please. So to conclude, CCS is vital to meeting net zero targets, and there has been very strong momentum in 2020. However, further scaling up is urgently needed. We need to move from having some 20 odd operating facilities today to having some 2,000 facilities by 2050. And to get there, we believe that supportive policy is required to create the right conditions in order to accelerate the deployment of CCS. From our point of view, at a high level, these policy priorities include creating conditions for investment, including putting a value on carbon dioxide emission and greenhouse gas emission reductions, facilitating development of CO2 transport and storage infrastructure, and clarifying key legal and regulatory issues. So in a nutshell, there's a lot to be excited about, but there's a lot more to do to get us to net zero and for CCS to play its role in helping us to get to net zero. With that, I would like to turn over to Jeff. Fantastic.
Thank you, Lauren. A great overview of what's happening around the world. And in just a minute, we're going to drill down into what's happening, particularly in the GCC. Lauren, there are several questions that came in with respect to are the slides available, or what is available after the webinar for the participants. I should have mentioned early on that we are recording this, and that will be available. The recording will be available on our website. Can you just talk for a minute about what kind of resources around both this presentation and the status report are available to the public?
Of course. So as you said, Jeff, our status report is available to download on our website. And we, as we've discussed, we're also having an Arabic version for the first time this year. And a lot of the, firstly, the information that we presented is completely from the status report. The charts are from the status report. And as you said, this webinar will be made available probably in a day or two on our website as well for all the participants. So they should be it should be possible for them to rewatch if they wish to do so.
Great, thank you. And one point of clarification that came through on the chart that showed the bar chart that showed the progress of CCS over the years. There was a question about whether the shift from 2019 to 2020 reflected our reclassification or whether it was an actual increase.
That's definitely an actual. That is definitely an actual increase. As I mentioned, it's that 17 facilities that have been added, and we also took out the 2 facilities that have suspended operations. So it's very much the actual increase.
Very good. There are several other questions. We'll hold those until the rest of the speakers are finished. So now let me introduce our next speaker, Robin Mills. And Robin, if you can turn your camera on and unmute, that would be great. Robin established Kamar Energy in Dubai in 2015 after working for Shell, Dubai Holding, and the Emirates National Oil Company. He's an expert on energy strategy and economics, and has been described by Foreign Policy magazine as one of the energy world's great minds. He's worked with a variety of international energy companies and governments on energy policy, renewable energy, carbon capture and storage, hydrogen, oil and gas upstream, and LNG. And we're very pleased to have Robin with us today. Robin, over to you.
Great, thank you, Jeff. Thanks, Lauren, and good afternoon, everybody. Very much looking forward to speaking to you all about the progress and the drivers for CCS in the Gulf region. So if we could go to the next slide, please. So I just thought it's useful to start by reminding ourselves of the scale of the challenge. The challenge, simply put, is that we have somewhat over 3,200 gigatons of carbon dioxide equivalent to fossil fuel reserves, but we have a carbon budget of somewhere between 460 to 1,200 gigatons, depending if we're talking about the 1.5 degree warming target or the 2 degree warming target under the Paris Agreement. And you can see from this chart that if you talk about the 1.5 degree target, that means you could burn perhaps about a little bit over half of global oil reserves and nothing else. If you talk about the 2 degree target, you could burn global oil and coal reserves, but not oil and gas reserves, but not coal. But of course, we're very actively burning coal at the moment in China, India, and elsewhere. So we've got to allow for a substantial amount of these coal reserves getting burnt, at least in the near future. So this is a big challenge for the countries that have large resources of oil and gas and naturally want to make the most of them. How do they do that in a climate compatible way? Well, they can focus on lower emitting resources, i.e. switching from coal to gas and switching to the lower emission options for oil and gas production. They can look at non-emitting uses, so petrochemicals, for example, where the end result is a solid product that isn't releasing CO2. They can look at carbon capture, use and storage in end use, so gas combustion, for example, in power or industry with CCS. There, of course, is biosequestration and bioenergy with CCS to draw down atmospheric CO2 directly. And then there's direct air capture using technological means to take carbon dioxide out of the atmosphere. And it's likely that we will need some combination of all of these in order to make a sensible but climate compatible use of oil and gas, and to some extent coal resources. And how much of this we can do is obviously a critical question for the GCC countries and the holders of the large hydrocarbon reserves. Next slide, please. So Galoran's already talked a bit about what the activities in CCS currently in the GCC. So operations so far are important and interesting, but relatively limited. 3 large-scale active projects that were mentioned: the Al Riyadh project on the Emirates Steel plant in Abu Dhabi, the Othmania CO2 EOR project in Saudi Arabia, and the acid gas reinjection from gas processing for LNG in Qatar. There are a number of other studies, projects that have been done looking at CCS for EOR, for example, in the Upper Zakum field in Abu Dhabi. There are some smaller CO2 recycling projects, for example, in Bahrain within industry, and there are some smaller scale CO2 capture projects for use. So, for example, in Jeddah in Saudi Arabia, the use in capture CO2 from industrial boilers for beverage production. Use in Kuwait, CO2 capture from ethylene glycol plant, and that CO2 is sold throughout the Gulf region in small amounts for various industrial uses. However, the ambitions are much bigger, and I think 3 countries again in particular stand out: Saudi Arabia and its circular carbon economy plans, which obviously relate very directly to the use, reuse, recycling of CO2 and carbon. Qatar's carbon capture and storage plans on its new LNG plans, planning to take them up to 5 million tons of CO2 captured by 2025 and ultimately to 7 million tons. And then ADNOC's ambitions beyond the Al Riyadh plant to get up to 5 million tons of captured CO2 by 2030. So I look forward to hearing from our colleagues on this call about those projects. Next slide, please. Now, CCUS, in the Gulf region is favoured by a number of characteristics of the Gulf, and one is that there's a limited number of large point emitters. The Gulf is a large emitting region, particularly if you look at CO2 per capita or per GDP, but that is coming from a relatively small number of facilities: some large oil and gas facilities, some power plants, oil refineries, LNG, gas liquids plants, iron, steel, and so on. So the task is large, but it's relatively manageable. It's relatively concentrated. And I've shown here the estimated emissions from these large point sources by 2025 for the 6 GCC countries. And you can see obviously Saudi Arabia stands out as the biggest emitter. The gas-fired power sector is a very important one. And then a whole bunch of industrial facilities of different types where capture on some of them, if we think about fertilizer plants, if we think about methanol, if we think about direct reduced iron plants, capture from those is relatively more straightforward. Gas to liquids plants as well. Then there's others where the emissions are more diffuse and harder to capture. And these emissions are clustered in a few large industrial areas, which typically are close to oil and gas fields. So ideal sites for these capture clusters, and Gloran showed how that works in Europe. And you can imagine a similar thing in the Gulf where a number of industrial plants can feed into a CO2 into a nearby oil or gas area. Coal plants, there are some plants for coal. Dubai started a coal plant recently. Oman maybe, probably not now actually, but at least there is some potential for capture on coal as well. And there's a significant amount of oil-fired plants, which includes integrated gasification, combined cycle plants, which again are relatively more favorable for capture. Next, please. And again, just emphasizing this point about the clustering of facilities, you can see the number of large emitters which are clustered along the Gulf Coast. And of course, that's also the center of the oil and gas production. You've also got the west coast of Saudi Arabia and the area around Riyadh, which are perhaps a bit more problematic, not so close to obvious sinks, but there's certainly lots of potential along the Gulf Coast. And the NOCs, the national oil companies, have a critical role to play in this because their emissions, the total emissions from them are up to equivalent to almost a third of the GCC's total emissions, and that is going to increase by 20 to 30% in the next 10 years. So there's a clear need for emissions reductions there, with an estimated cost of 40 to 60 billion, a very large investment to make sure that those emissions are not in fact increasing. So next, please. And we've looked at the technical potential for capture. So this here is really showing what would happen if the Gulf region went all out for CCUS and built facilities on all the major sources that could be captured relatively easily. So this is not a prediction. I mean, things will not go this quickly, of course, but it's a kind of showing the outer boundary of possibility. And you can see there's a number of capture sources that I've talked about. You know, gas processing is an obvious one, gas to liquids, and then the various industrial processes. And then at the top of the chart, some of the more difficult ones, the more challenging capture sources. Cement is a very large one. Gas power is significant as well. So realistically, I think given the plans that are being that are actually active, we'd see about 11 million tons a year captured by 2026. So, you know, technical potential is about 70 by then. Realistically, we could be 11. So that's good progress, but obviously still a lot more need for accelerating this. And we've really focused here on the three leading countries for CCUS, you know, Saudi Arabia, UAE, and Qatar. We have not seen much activity in the other three GCC countries, and we need to. We also need to see some progress from them, and I see Oman as quite promising as well, but not too much in terms of tangible projects yet. Next, please. And the hydrogen picture is also a very important part of this. Over the past year, we've seen a lot of very interesting progress on hydrogen, and the region's identified that as a key source of future energy and future competitive advantage. We've seen some quite significant announcements from Saudi Arabia and from Abu Dhabi in recent months. Those relate both to blue and to green hydrogen. So the GCC already uses large amounts of grey hydrogen, and that is hydrogen produced from fossil fuels, you know, primarily gas, but without CCUS, an emitting source. And particularly that's used in Qatar for the gas to liquids plants, which require large amounts of hydrogen for their internal use. So most of this is really internal generation of hydrogen within plants, that is particularly refineries, GTL plants, which is then used for their internal process. This is grey, of course. So to improve the carbon footprint of this, we need to turn into blue hydrogen by using CCUS. And you can see on the right side the blue and grey hydrogen production costs by region, and the Middle East has potential advantage. The costs for hydrogen production, blue hydrogen production with CCUS is significantly lower in the Middle East than in other regions. So you can see hydrogen production of about 1.5 at about $1.5 per kilogram in the Middle East, and that's more than competitive with anywhere else. And this is a significant opportunity, but we need to see a business model for this to install CCUS on hydrogen production in the Gulf. The Gulf has great potential, as I say, for blue hydrogen and for green, but there needs to be a premium paid or a carbon charge or some advantage for producing low carbon hydrogen. So next, please. Okay. So that was a pretty quick run through the GCC and the overview of the advantages and opportunities. I'm very much looking forward to hearing from the other panelists.
Excellent. Thank you, Robin. A great way to start with the discussion of what's happening in the particular region. Our next speaker is Tijani Nias. Tijani is the CCUS lead for technology strategy and planning for Saudi Aramco. He's currently co-leading the Mission Innovation Carbon Capture Challenges and is actively engaged in various international collaborations on CCUS, such as the Oil and Gas Climate Initiative, OGCI, the Carbon Sequestration Leadership Forum, or CSLF, and the Clean Energy Ministerial CCUS Initiative. Tijani, over to you.
Thank you, Jeff, for the opportunity to speak today. And so I will be providing some overview on what's happening in Saudi Arabia when it's come to CCS. Next slide, please. Okay, so I will start first by explaining the energy and environment situation in Saudi Arabia, so you better understand the context in which CCS is being developed. So as you know, the Kingdom of Saudi Arabia has abundant energy resources, not only in the form of oil and gas, which most people know, but also in the form of solar and wind energy because of the country's geographical location. So I think Kevin has referred to that one, Robin, sorry, in the previous presentation. The country has moderate absolute CO2 emissions of about 600 million tons per year, but the emissions per capita are quite high compared to similar economies because of the high reliance of the country on hydrocarbons to drive the economy. But most importantly, the environment in the country is quite tough, with harsh and hot weather, where the outside temperature could reach 45 degrees Celsius, during the summer. So water, food are scarce, and actually water desalination and air conditioning are significant contributors to the kingdom's emissions. So any climate strategy, including CCS, has to be put in the context of the food, water, and energy nexus, which is very central to the country development agenda. So in this context, the big question is, how CCS is addressing this challenge of providing quality of life in the country. So CCS actually, in this context, aligns very well the economic development aspirations and the environmental challenges, because it provides a clear pathway to addressing some of the long-term aspirations of the kingdom's development through the Vision 2030, including economic diversification, that I'm going to explain in the next slide. So, I mean, having this context in mind, I think, can you go back to the previous slide, please? Previous slide, please. Okay, so having this context in mind, I think any emissions management or any climate change strategy would have to be a holistic approach that integrates both the natural resources endowment and, most importantly, also the environmental challenges. Next, please. Okay, so that holistic approach that I just referred to is the circular carbon economy framework. The kingdom has been promoted extensively during last year G20 presidency, and which was also endorsed by the G20 leaders as a holistic, inclusive, and pragmatic approach to promote economic growth while enhancing environmental stewardship through managing emissions in all sectors, including energy, but also industry, mobility, and food. So here you see the narrative that I was referring to, that we need to have a holistic approach that look at what are the key elements of CCS in addressing the energy water nexus. So just in a nutshell, the circular carbon economy framework is based on the 4R principles that are built on the principles of the circular carbon economy that we are all familiar with, which mostly focus on material flows to minimize waste. But the circular carbon economy is focusing on emissions flows because we believe that reducing fossil fuel consumption only or reducing CO2 emissions only will not be sufficient to take us to the ambitions of the Paris Agreement. So there is definitely a potential to look at how we can reuse emissions, how we can remove them from the atmosphere, how we can recycle them into the economy. So those are the key principles of the circular carbon economy. So under reduce, for instance, we will have technologies such as renewables, energy efficiency, hydrogen, but also carbon capture. Reusing emissions as working fluids for food and beverage or enhancing the extraction of hydrocarbons is also something that could add value to the economy while also reducing emissions to the atmosphere. So recycling emissions in the form of synthetic fuels or bioenergy is also very attractive, mostly in the longer term, when we'll have to remove CO2 from the atmosphere in order to achieve the balance between emissions and the things. And as it was presented previously, so that is going to be extremely critical for achieving any net zero target. So removing emissions from the atmosphere through nature-based solutions or industrial processes such as direct air carbon capture or bioenergy with carbon capture is also key to the circular carbon economy framework. So now looking back at those 4 R's, you can see clearly that CCS is really central to the circular carbon economy and is contribute to both reducing, reusing, recycling, and removing emissions. And it's not only addressing the emission flows as we used to know and report emissions on a yearly basis, but it's also address the stock of emissions in the atmosphere and also what we can store underground through CCS. Next slide, please. Next slide. Okay, so just in terms of value proposition for CCS, because we always talk about the importance of CCS in many different reports, including from the IEA or from the IPCC. But if you look closely at the value proposition of CCS for the Kingdom of Saudi Arabia, it's quite impressive that what CCS can deliver to the local economy. And CCUS do have a very strong value proposition for the country. I will just mention a few of them. First of all is definitely, an emission management solution across all key industry sectors, including energy production, manufacturing, and also mobility through hydrogen. It's contribute also to the economic diversification, which is central to the Kingdom's long-term 2030 vision. By building a new low carbon industry and also supporting low carbon oil exports through removal of CO2 from the atmosphere. So this is in addition to helping maintaining or creating new jobs in key industrial clusters, as it was presented earlier. So in the Kingdom, we do have concentration of industrial facilities in the Eastern Province and also in the Western Province. So CCS can help maintain and expand those highly skilled jobs. CCS will contribute also to decarbonizing industry sectors such as power, water desalination, oil and gas, chemicals, and the industry at large, including cement, aluminum, iron and steel, etc. Chemicals also is very important. So enabling the production of I would say, CO2-free hydrogen and other low carbon products, as we just mentioned, can be achieved also through CCS. And most importantly, in a carbon constrained world where countries set ambitions for net zero emissions, some countries will not have the opportunity to store CO2 domestically because of their limited storage capacity. So in the longer term, CO2 import and storage as a service could be also a significant addition to the kingdom's economy, given the potential storage location in the kingdom. Next slide, please. Now, when it's come to technical expertise in Saudi Arabia, there are significant CCS capabilities in the kingdoms, covering both research and development technology with large-scale pilot demonstration in operation that I will highlight in the next slide, and also through CAPSARC, we're conducting studies on policies and market mechanisms to guide decision makings when it comes to scaling up CCS. So the R&D focus is mostly on improving CO2 capture performance and reducing the cost of carbon capture, and also enhancing the use of CO2 into synthetic fuels, chemicals, or mineralizations in order to create or to support the objective of circular carbon economy by making use of CO2. At the government level, the Saudi Ministry of Energy is also a key and leading member in global CCUS organizations such as the Mission Innovation, where the country has been leading the Carbon Capture Innovation Challenge, and also playing a key role in the Clean Energy Ministerial CCS initiative, and has been also a key member of the Carbon Sequestration Leadership Forum for many, many years. So now I will just give you, given the limited time, I'll give you a flavor on what are the flagship CCS project in the kingdom. Next slide, please. So my company, Saudi Aramco, is operating one of the first large-scale CCS project in the region since 2015. So the project has the capacity to capture up to 0.8 million tons of CO2 per year from a natural gas liquefaction plant located in Hawiyah, as you can see on this slide. The CO2 is then purified and transported through an 85-kilometer pipeline and injected in the Osmaniya field, which is part of Gawar, one of the world's largest onshore oil fields. So the project actually is equipped with an extensive CO2 monitoring and surveillance program with more than 1,000 seismic sensors to monitor the CO2 the sequestrated CO2 underground, the CO2 plume evolution, and also the CO2 breakthrough speed. The sequestered CO2 through this project is actually above the industry average because of the sophisticated monitoring and surveillance program that is in place. But I have to stress here that Saudi Aramco doesn't need CO2 enhanced oil recovery as part of its operations. Most of our reservoirs are still very young, and our cost of productions are also very low. So this Osmaniya CO2 EUR project is a research project only, and contribute to improve our understanding on how CO2 behave in our reservoirs as part of our long-term resource planning. Next slide, please. There is also another large-scale project being operated by SABIC, a chemical company based in Saudi Arabia. So that project is capturing up to 0.5 million tons of CO2 per year since 2015, and use it from an ethylene glycol plant and utilize it for the production of methanol, urea, and liquid CO2 for food and beverage. So this is also one of the world's largest CO2 utilization project in the chemical industry. I think this concludes my presentation. I hope I did not exceed my time slot, Jeff. So thanks for listening. I would be happy to take any questions. So back to you, Jeff.
Excellent. Thank you, Tijani. A really terrific overview of Saudi Arabia and Saudi Aramco's approach to CCUS and the circular carbon economy. Next, we'll hear from Aisha El-Kabali from the Abu Dhabi National Oil Company. Aisha is a specialist in reservoir engineering in the Enhanced Oil Recovery Division under ADNOC Upstream. And she is currently overseeing CO2 integrated strategy and often presents ADNOC's CCUS efforts both internally and externally. She's leading the carbon capture, utilization, and storage projects in Abu Dhabi and is actively engaged in international workshops and events on climate change and other sustainability aspects at ADNOC. Aisha, over to you.
Assalamu alaikum. Thank you, Jeff, and thank you to Global CCS Institute for your invitation to participate in this webinar on behalf of ADNOC alongside such a distinguished panel, and it's my pleasure to be here today. Next slide, please. So first of all, let me talk a little bit about our commitments in UAE. So UAE is committed to climate change plans through many initiatives. And UAE was the first oil-producing nation and the first OPEC member to sign Paris Accord for the global temperature. And in ADNOC, we believe that CCUS is one of the key innovative solutions to mitigate the climate change while still meeting the global energy demand. And in ADNOC also, this is continued to be our focus as part of the sustainability strategy. So what is the key drivers for the CCUS efforts and strategy in ADNOC? I will highlight some of these points, starting with the environment. So as CCUS is part of the sustainability strategy, it helps in impacting positively in the environment by reducing the carbon footprint and still meeting the global energy demand. Another driver is the production for the sustainability and the long-term plans. So CCUS is playing a role in order to achieve the 70% recovery factor aspiration for the long-term plan. And also it will help us to unlock new potential resources as our field getting mature, where it will help to sustain the production for the long term and will reduce the carbon footprint at the same times. Another driver is currently we are injecting gas in some of our fields, and CO2 is a good candidate for the replacement. And this will help us to avail additional gas to the network. And this is in line with the gas self-sufficiency strategy of ADNOC. So how we can achieve all this? ADNOC is working closely with different partners and different global institutes in order to develop further concept for the CCUS. In parallel, we are working to develop R&D program which will help us to utilize the latest technologies for capturing and to lower the cost in order to have at the end an economic and profitable, successful CCUS project. Next, please. So now let me take you through the journey of the CO2 and the CCUS in ADNOC. So in ADNOC, we start to pilot and inject CO2 in 2009. And with that, ADNOC was the first oil and gas company in the Middle East to pilot CO2 injection for the enhanced oil recovery purpose. And in 2011, Riyadh has been executed as the first world commercial scale CCS facility to capture CO2 from the steel industry. And it is the largest CO2 project in the region, where we start in 2016 to produce from 2 of our ADNOC onshore fields by injecting the carbon dioxide safely under the ground. And for this project, we have an extensive data acquisition to understand the process more and to increase our knowledge for the future plans. And as part of our CCUS roadmap, in the upcoming 10 years, ADNOC momentum and investment will continue, where we have planned to increase our demand sixfold the current CO2 injection from our own operation. In addition to that, we have a new hybrid technology where we have a CO2 mixed with chemical to be piloted in the upcoming years. And this is an innovative hybrid concept where it will be first industry to be applied in the upcoming years in ADNOC onshore fields. In addition to that, I would like to highlight and emphasize about the point of the collaboration, where a collaboration is a key factor to success in CCUS. And we are working with a different institution to develop further a new concept. In addition to that, I would like to highlight that recently we signed a different agreement and strategic framework with Total and recently with Japan also, in order to have a collaboration in a CO2 recycling technologies. And also, we are having different initiatives in terms of the CO2 with the hydrogen. And we believe that hydrogen has a potential to be a game changer in our global efforts toward the energy transition. Next, please. And now, let me talk a little bit more about our successful story, Al-Riyada. It has a different uniqueness project in terms of this is the first fully commercial CO2 capture from the iron and the steel industry, and the first Middle East commercial scale CO2 capture plant, which started in 2016 with a capacity volume of 800,000 tons of CO2. And this is equivalent to annual CO2 sequestration capacity of 1 million acres of forest. So we are capturing the CO2 from the steel industry, and in Riyadh we are doing a lot of process such as a compression and dehydration in order to make that the CO2 is suitable to be injected in our field. And from Riyadh, it goes through a pipelines to be injected in our ADNOC onshore fields. In addition to that, this helps us to EUR purposes, to free gas, and to reduce the carbon footprint, which will impact positively in the environment. Next, please. So for the upcoming years, ADNOC momentum and investment will continue, and we identify two potential sources of the CO2 from ADNOC gas processing and ADNOC sour gas. And this will help us to increase our CO2 injection, and this will be aiming to achieve 5 million tons of CO2 every year by 2030. And this is equivalent to the annual carbon capture capacity of over 5 million acres of forest, which would be a forest over twice the size of the whole UAE. In addition to that, we believe that also hydrogen will play a major role, and it will have a potential to be a game changer in our global efforts toward the energy transition. And our long-term aspiration to become a global leader in industrial CCUS EOR activities and to make the UAE one of the leading countries in this area. So we are working in different projects with the latest technology in order to have economic and efficient CCUS project, which will impact in the environment and will reduce the carbon footprint while we are still meeting the global energy demand. So in conclusion, our UAE commitment will continue to achieve our aspiration, our ambitious CCUS strategy, and to reduce the carbon footprint while we are still meeting the global energy demand. And the collaboration with these different global leading companies will help us to further mature the different concepts in order to have an economic projects and successful. And with this, I conclude my presentation. And I'm happy to have, if you have any question, I'm happy to answer the question. Thank you. Back to you, Jeff.
Very good, Alicia. Aisha, thank you very much. And it's really exciting to see all of the progress and activity and investment that's occurring in the region. The progress that we'll see in the region will extend beyond the region because the more momentum that we see across the globe, of course, the more that enables more projects across the globe. I'm going to ask all of the participants now to put their cameras back on, but stay on mute until until you want to address particular questions that have come in. And as usual, we've had more questions than we have time to answer. We've had about 40 questions, but there's some themes that are emerging from those questions, and I'm going to try to ask questions to the panelists that may incorporate several of the questions that have come through. The first question I'll ask to actually all of the panelists is with respect to policy, and that relates also to the economics of investing in particular CCS projects. So perhaps we start with Robin on this. You can talk about what policies are required by the governments in the region. Aisha and Tajani, certainly if you have perspectives on what's happening in your particular countries, that would be great. And then Lauren, if you can kind of come out from the region and talk about what policies are incentivizing CCS projects around the globe. So Robin, if you would start with what policies are required to incentivize CCS projects in the region, and then we'll go from there.
Yeah, sure, Jeff. Yeah, thanks. So look, I think there are really three sides to that. So, you know, at the moment there isn't a carbon price or a kind of carbon trading scheme in the Gulf, and probably not likely to be for some time. So CCS projects really have to be justified, I think, in at least one of three ways. You know, the first way is as a mechanism to assure continued market access, right? So we've seen growing talk in the EU about carbon border tariffs or carbon footprint standards on imported products into the EU, and that would include oil, gas, but energy-intensive materials, aluminium, steel, and so on, which of course the Gulf is an important producer of. So if the Gulf wants to continue to have access to the European market, it will need to either impose some kind of a carbon charge or a carbon footprint standard. And I think we can expect those standards to extend to other countries that have made zero carbon commitments. That could include Japan, obviously a very important market for Gulf oil. At some point it could include the US and others. So that's really the first part. The second part is, you know, is where CCUS can be justified in terms of the benefits of EOR or the benefits of CO2 recycling in some other way. And obviously CO2 recycling is already pretty widely used in the urea and methanol industries because it just makes economic sense. But EOR economics in some countries, and you can see, you know, I think we heard from Tajani in Saudi Aramco. Saudi Aramco doesn't need EOR right now, but there are other mature fields in the region. You know, if you look at Oman, for example, particularly, where definitely EOR makes economic sense. And then the third area is I guess a bit of a subset of EOR, but that's in replacing natural gas injection for enhanced oil recovery, supplementing it or replacing that with CO2, and therefore benefiting from the value of the gas that can be used for something else. And Aisha mentioned that as an important an area for ADNOC's policy. So I think those are the three key drivers.
Yeah, thank you, Robin. And Tajani, why don't you start with Saudi Aramco, and not just what's in place and kind of the current drivers, but if there are policies that need to be implemented to further encourage CCS in the kingdom, would be great to hear your view on that. And then Aisha, we'll go to you with the same question for the UAE.
Well, I mean, thanks for the question. Just for the EOR project in Aramco, and even for the CO2 to chemicals project with and SABIC, there were no policy in place in Saudi Arabia to support those projects. So those projects were fully managed by those state-owned companies. Now, what's happening at the kingdom level is that under this circular carbon economy framework, the kingdom has announced the development of a national program on the CCE in the circular carbon economy. And that national program has the ambition to achieve some level of carbon capture in the kingdom that would definitely require a policy instrument or market mechanism in place to catalyze the development of CCS. So things are being under development, but options for CCS will be most likely what is happening in other jurisdictions, like in Europe or in the States, such as tax credits or CCS obligations, or CCS public procurement, by which the government will commit to buy a certain amount of low carbon products in the form of electricity, of hydrogen, or whatever, but obligate the private sector to do so. So we could also think of an emission performance standard, by which, for instance, you set a carbon intensity on a product to regulate the market. So if you look at the from under this, for instance, policy measures, actually, in the oil and gas industry, Saudi Aramco has the lowest, upstream crude carbon intensity, which is around 10.2 kilograms of CO2 per barrel of oil produced, which is much below the average industry carbon intensity. So policies are being studied, are being developed, but I think they have to be put in the context of the country, because not all mechanism or policy mechanism will have to work in the country if we want to deliver a CCS at scale.
Thank you, Tijani. Aisha, thoughts on policy from your perspective in UAE?
Thank you for your question. I think globally in the US, we are using different policies. And currently here in Abu Dhabi and in ADNOC, we are working in different CCUS projects and CCUS initiatives with the current situation, and the main driver is for the sustainability, as it is part of the sustainability strategy in ADNOC, and for the enhanced oil recovery for the long term to sustain the production for our fields. In addition to that, the gas self-sufficiency, where we can inject CO2 for the replacement. So this is our current situation. And we are also, as part of the sustainability strategy, we are aiming to reducing our carbon intensity by further 25% over the next 10 years by enhancing the efficiency and expanding our industry scale of the CCUS facility. This is mainly here for the CO2 and the drivers in ADNOC for the project for the long term and the future projects for the upcoming 10 years. This is mainly our initiatives and our focus in terms of the environment and in terms of the enhanced oil recovery, and to achieve the 70% recovery factor as an aspiration for the long term, and to sustain the production as part of ADNOC 2030 smart production growth. This is in brief about our main drivers and main activities, without highlighting the impact on the future. And this will be basically in terms of the activities and different projects and initiatives in ADNOC.
Thank you. And Glorin, perhaps a quick comment on best practices globally.
I think I'm just going to echo what our speakers said and point out that it's important, and we see that it's important for the governments to help make the business case for CCUS through supportive policies and reduce risks that the private sector is not in a great position to. Private sector can of course take project specific risks, but there are some harder to reduce risks such as regulatory framework related to the regulatory framework. So it's important for government to create a supportive environment, but also want to echo what Tijani was saying, i.e. there will be different sort of policies potentially depending on the local context. So for example, as Robin said, it's important to put a value on carbon CO2, but it can be done through a carbon price, carbon tax, or as in the US, a carbon tax credit. So it doesn't have to be one size fits all, but I think the local context, government's ambitions, such as in the case of ADNOC and the UAE, from commitment to sustainability and decarbonization, are all going to be important drivers.
Yeah, great. So I'm going to ask one more question. I know we're just at time. I want to go just a few minutes beyond, if it's all right with the panelists. There's a lot of questions that are coming in around the cost of CCS. And of course, policy and revenue is one side of it. The other side of it is cost. Robin, what's happening with the cost of CCS? Can you give folks ballpark estimates on the cost per ton for capture and storage and the trajectory of that? And again, we'll also ask the other panelists for their views on that.
Yeah, well, look, Jeff, that's obviously highly dependent on the kind of capture we're talking about, and I think that's why I showed in my charts I tried to differentiate the capture per source, because we know that trying to capture from highly concentrated sources is far easier. And I mentioned direct reduced iron, which of course the Emirates Steel plant in Abu Dhabi uses, ammonia, fertilizers, methanol, so on. Those are all ideal forms of capture. Power plants are more difficult, and then things like cement and so on get particularly costly. But I think we're really, and I kind of defer to the GCCSI colleagues here, but I think we're looking at, perhaps at the range of $20 a ton capture prices for some of the easier methods, up to 80, 90 for the more difficult ones. And that's in terms of capture. Transport over short distances, a few dollars a ton, perhaps less. And storage, again, very dependent on the storage site, and injectability, well costs, and so on. But again, a few dollars a ton, perhaps going up a bit more and more difficult, challenging areas. I think the Gulf injection conditions are particularly good. Obviously, if you have EOR credits, that's that can make the cost of storage effectively negative. And really, reducing these costs, as we know, is a function of experience and learning and doing major projects and getting better at them. And we've seen, a lot of promise in learning from a few large-scale plants that have been done in North America so far. And there's also some pretty exciting developments on the horizon. And I point to the Net Power project in Texas on a gas-fired, a new form of gas-fired power using CO2 with extremely low capture costs, extremely high efficiency. That's a very exciting technology, and I think we're hopeful if that can make progress, that would be really tremendous.
Any other comments on the issue of cost?
I think Robin captured it very comprehensively, and I've seen some questions about sort of the region, how the GCC compares to the rest of the world, and some questions around transport and storage costs. And obviously, as Robin said, it very much depends, for example, when it comes to transport, how the distance between the capture source and the storage site, in terms of kilometers, onshore, offshore, and whether kind of it's depleted oil and gas reservoirs or whether geological storage, etc., all kind of determine the cost. In Northern Lights, they're going to be using tankers, which is a more costly and innovative, but a bit more costly way of transporting CO2. And I think with all those, when we take all those factors into account, it's very, and as we heard from the speakers, GCC is very cost competitive, is a very cost competitive location region in terms of transportation and particular storage of CO2, with reuse being a kind of reuse of infrastructure being, of course, and also potential cost reduction opportunity.
Great. Let's leave. Oh, so go ahead, Johnny. Yeah.
Just wanted to add to what Robin said. There is no cost for carbon capture. The cost of carbon capture varies between $20 per ton all the way to 100 based on the applications, and also the proximity to geological storage. So, but the important point, in my opinion, is what the institute presented through in the report about this concept of CCS hubs or cluster, where we share the transport and storage infrastructure. To me, this is a kind of a game changer in the CCS space, because it's reduced the risk and also reduced the cost of transport and storage, since this is a shared infrastructure that a government could, for instance, put in place. And the cost of transport and storage is will be shared. But most importantly, most of the emitters don't have any knowledge or any expertise in transporting CO2 and even in putting it underground, because this is not part of their core business, right? So now if a government or an oil and gas company is offering that service, that would definitely, you know, bring a completely new perspective on the carbon capture cost, which could again, you know, be all the way between $20 to $100, depending whether you're capturing the CO2 from a natural gas plant or a fertilizer plant or a cement plant. So the last point that I want to add also is that carbon capture cost is important, but the complexity of the capture also is another parameter. If you look at the CO2 capture from a refinery, it's maybe economical, it's maybe cheap, but it could be very complicated because of the distributed nature of different refining processes, you know, within the same premises.
Great advice, Tijani. Thank you. Let's close up there. We have gone just a bit over time, and I want to respect folks' schedules. Sonia, if you could just go to the upcoming event slide. There we go. I'm going to leave you with a couple of additional, some bits of information for additional information. The 25th, later this week, we'll have another webinar on CCS and net zero targets in Europe. You can follow us on social media, LinkedIn and Twitter. And if you do have further questions for us, there are a couple of email addresses that are there on your slide. Also, I think you can reach out to any of us through LinkedIn. If you have a particular question that didn't get answered today that you'd like to follow up on, certainly reach out to any of the instituted web addresses that you see there. With that, I want to just thank first our panelists, Lauren, Robin, Tijani, and Aisha for participating and sharing your perspectives today, and also thank all of you who spent time out of your day today, some of you getting up quite early to participate in the webinar today. Many thanks to everyone, and looking forward to seeing you on the next Global CCS Institute webinar. Thanks again. Have a great day.